Current zymographic techniques detect a limited number of proteases. Fluorescent peptide zymography uses fluorescent peptides as the degradable substrate, enabling measurement of a greater range of proteases. The main advantage of this method is its modular design. The sequence of the fluorescent peptide determines which proteases are detected, and the fluorescent peptide can easily be swapped with a peptide of a different sequence and ability to detect other proteases.
This technique can help inform the design of peptides used as degradable crosslinkers in engineered biomaterials, such as those used for drug delivery or tissue engineering applications. Incorporation of this peptide into this technique can identify tissue-secreted proteases that are responsible for biomaterial degradation. Demonstration of this technique is important in order to visualize the multi-layer approach that is unique compared to other zymography techniques.
Demonstrating this technique will be Ameya Deshmukh, a graduate student from my laboratory.
To begin, prepare a 10% polyacrylamide resolving gel solution as outlined in Table 1 of the text protocol. Immediately prior to pouring the gel, add the TMed and APS. Then, fill an empty 1.5 mm mini gel cassette halfway with the resolving gel solution. Add a thin layer of isopropanol to the top of the polyacrylamide gel to produce a level gel and prevent bubbles. Use the leftover polyacrylamide solution to track the progress of the polymerization reaction. When the polyacrylamide in the tube has completely solidified, the reaction is complete. While the first resolving gel layer is polymerizing, retrieve the azido